This conference will now be recorded.
Right. So right, just we visited this group architecture generation one, and even we identified the daemons or services in terms of storage and processing.
Yeah,
So even at the same time, we identified the limitations also, right?
yeah.
So in tomorrow's class, we can discuss about the features, new features, how they are, the limitations addressed really, and those things we'll visit tomorrow session, conceptual thing. Today, what I will show you, I'll show you that important configuration files and how to start and stop the Hadoop services, and with some basic Unix commands what you need really, and followed by we'll run some Hadoop commands as well. So as a developer, what exactly the essential commands that we need, right? Of course,
Okay.
well, there is a lot of commands will be there, but we go through some important commands which are really useful as a developer. Okay, all right,
Yes.
fine. So let us start. So this is the machine that what I'm going to share to you today or tomorrow morning. I will upload off my local time. So anyway, so you're using Windows machine or Mac?
Windows?
Okay, fine. There is no issues then. Because MacBook means this particular VM will not work, so you have to go with VMware Fusion or something else. That's the reason I just asked. All right,
Yeah, yes.
fine. So here already we discussed, right? Hadoop cannot be installed on Windows machines. So in real time also you'll be getting the installations on either in generation one or two, whatever it may be, on Linux machines, probably on Red Hat Linux or Ubuntu or CentOS like that. And here the machine what you're viewing at present is something like this is Ubuntu 14.4 version. Of course, a lot of Ubuntu 16 and 18 also in the market, but it doesn't give any difference when you are using a 14 machine or 16 machine. At the same time, in real time, we'll be using generation 2 or 1, whatever it may be, the Hadoop, 64-bit Hadoop. Okay, we'll be using the 64-bit Hadoop. But in this machine, just we configured the 32-bit only. Okay, so for example, if you go and try to download the Hadoop generation 1 or 2, whatever it may be, for example, Hadoop 2.3.0 download, if you're saying like this, or 2.2, whatever it may be. So the version what you're going to download this Hadoop 2.2.2 .zz. So this is the default is a 32-bit actually. Okay. So but what they will do is real time. They will download the source files. Here you can see the source file. So they will download the source file and they will compile this into the 64-bit Hadoop. Okay, so that's what exactly happens in real time. So by default, whenever you're downloading any targets files, like not only Hadoop, big or high, by default they will give some support for the 32-bit. So here you will be getting something right, Hadoop 2.2.2 tar.cz. So it's a compressed thing, that's it. And thus purely, is a 32-bit operating, sorry, not operating, 32-bit Hadoop version. Okay, so in real time, they'll download this one, source dot src.tar dot these are these, right? So they will download this one and they compile into 64. That's fine. Now at the same time, while installing and configuring, we need to go with the proper Java version also. So if you're working on the generation 1 machines, so 1.6 is the a good choice. So if you're working on other than one other than, I mean to say, 2.1 or 2.2, 2.3, 2.4, like the way some major versions or minor versions, whatever it may be, then the recommended Java version is 1.7 or 1.8. So we had to go through the topology documentation, and based on that we had to set the appropriate. Java also. And Java also has to go with the 32-bit only. As we are installing the 32-bit Hadoop, so you have to go with the 32-bit Java only. Okay. So suppose if you are installed any 64-bit Java, so it won't work. So you have to look for that, right? Right. And even the Ubuntu machine I'm showing is also 32-bit only. That's fine. Anyway, that's about some key points that you have to keep in mind when you're working on top of Hadoop. So only thing is in real time, everything is on top of 64-bit only. That's it. That's a conclusion I can say. That's fine. Now, see here, generally people will go with different users. Like, here I have not created any specific user for Hadoop. So my root user will be acting as my Hadoop user also. So I have not created any roles or user accounts, nothing, because this machine is not in the network. So no need to worry. Okay, so no need to create any specific user for Hadoop or someone else, because this is a machine we are working as a standalone and not in the network kind of thing here. So if you click on this home, you'll be getting a lot of folders, right? Like you'll be getting some Apache Hive, Maven, and Hadoop 2.3.2 and some other. You'll be getting some installation folders. So initially you'll be getting something like like this .zz, and we'll be extracting, and after we'll be configuring these things. Okay, so that's a good thing. And before going further, please let me know uh, what's the comfort level of this Unix. Are you good in Unix, or you can rate yourself as an expert or intermediate level or a basic beginner level? Have you any idea before? Any Unix commands or shell scripting, whatever it may be? Yeah, Naresh, can I get a quick response? Yeah, Naresh, are you there? Hello. Hello.
This conference will now be recorded.
Like, just I was asking you, like, what's the comfort level of Unix commands and all?
Unix, I'm not that much familiar with the Unix.
Okay, right. So coming to this, the home, what I'm showing, it's a installation photos that you're getting here about this Hive, HBase and everything. Okay. So initially you'll be getting some TCs and nothing but in a compressed format. WinZip or WinRAR we are having, right? In a similar fashion, we'll be having some tar files and CZ, some compression techniques they will use, and they will compress and they'll keep this. That's fine.
So, like Kafka file means compressed files, correct?
Yes, correct. It's a compressed files only. So we have to extract that. Then you'll be getting a folders like this. So you'll be having a setup like this, and we have to configure. We have to go with some installation steps and procedures. Then you'll be getting. So interesting thing here is like everything is configured here. Okay, no need to do any additional configurations to work with Hadoop. That's fine. Now, so coming to this, some important points that in terms of Hadoop. So if you click on here, Hadoop 2.3.0, you'll be getting some subfolders like bin, etc, include, like this. And apart from that, there is some important files to remember. One is the etc and one is the sbin and the other is the share folder. So we'll go one by one here. So coming to this etc, if you look at here, you'll be having some XML files. So core site.xml. I will mark some important files here. So Hadoop env.sh, nsite.xml, mapredsite.xml, and what are the other things? Yes, sdfs site.xml. So these, apart from of course all the slaves is also there, but not required really here. So these are the some important configuration files that we need to configure. So the moment you have downloaded Hadoop, actually you'll be having something like notepad kind of thing, a plain paper kind of thing here. So we had to go through the documentation, and based on that we had to set some properties. So once you read the documentation, there they will specify what has to be configured in this core site XML, what has to be configured in this HDFS site XML and the mapred and Hadoop env.sh. So these things will be specified very clearly in the documentation. For example, if you click on this HDFS site.xml, so here you can see this. This already right? DFS.replication I said 1. So if you're not keeping this parameter, what happens? You will be getting three replicants, because this is a single node machine what we're going to refer. Here we don't have any multiple nodes. So here master demands and slave demands, everything running on the same machine. Okay. Real time what happens? Master demands will run on separate machines, like your name node, job trigger will run separately on separate machines, and your task triggers and data node will be running on the separate machines. Got
Okay.
it? But
Yeah.
here, coming to this machine, so everything is running on the single node. So we don't have any separate setup for name node, data node like the way. So everything is running here only. So that's the reason what we did here. We did the DFS.replication property set to 1. So by default, 3 replicants. So we are overriding that property by setting the property here. Similarly, where you want to keep your name node data and the data node data and fs image where you want to keep, and log files where you want to keep. So like the way, just about the storage level, everything, all parameters. And of course I have not given here the default block size in generation 2 is 128 MB. Suppose you want to change that parameter, you want to give some value other than 128. For example, you want to give some 256 MB or 512 MB like the way. So that particular parameter also has to be set here only. Okay, the block size what you are looking. So you have to keep that block size here, and you have to save this before starting the Hadoop daemon. Got it? So like the way you be having some important files. For example, coming to this core site XML. So here we be saying, what is your host local host port number. So where you want to run your name node. So for example, 9000 I have given. In real time, maybe this port is busy. Okay, 9000 port already some other services are running. So your admin people, what they will do is they will go with some 8020 or 8021 kind of thing. They will assign the different ports. But assigning the ports and all also, there is some, some rules and regulations or guidelines that we can say. So Cloudera, Hortonworks, and even the Apache Foundation also suggest some port numbers, default ports. So universally that will be same most of the cases. But if already the port is engaged with some other, then of course your admin can take a chance to modify that. Okay. For example, Zookeeper generally runs on the port number 2181. And what I did in my machine, so I have for the running of Kafka, I have changed the default port to 5181 because the service is interrupting that. So default configuration I changed based on my convenience. So like that way you can go with your own port numbers also, but some recommended ports numbers and everything will be specified. So we have to go through the documentation part. So before changing any parameters here, right? So what ports you are looking for, So everything like where you want to go with your name node, data node, where you want to the listener, what we can call. So those related stuff will be maintained under the core site XML. Similarly, we are having one more thing called Hadoop env.sh. Okay, so here the important thing apart from all this is the Java home path. Okay, so we have to set the Java home path. That's it. So if and all you want to change the heap size, I mean to say, see for example, here they have not given anything, but here I changed my Java home because I'm running with 1.8 Java in my machine. So just I have configured this into Java 8 I have given here. So this i386 means I'm running a 32-bit. Okay, so this i386 means I'm running a 32-bit Java in my machine here. So this is the important. And apart from this, you can go and configure the heap size and all the memory configuration, also the buffer sizes and all. So here I left blank. I have not configured anything. In real time, what happens? Even this also will be configured based on how many applications that you want to run at a time. Based on, it depends only on the cluster size. But here our machine is a very simple one, and we are not running those many applications in parallel. So default heap size will be fine. So no need to change anything. So that's the reason we have not given any values here. So like the way here, that all the configuration files, okay, will have their own importance and significance. Similarly, of course, we have not discussed the second generation Hadoop architecture and all. Then you can understand what you mean with it, NSI.xml, okay, and all. So here you can see this. So what I'm saying here, open with gedit. Gedit is the editor here, like a VI editor. VI is one editor, and the gedit. So we are having certain editors, in this Linux machines. So generally the guys who worked on CentOS or Red Hat, they are familiar with VI editor. But coming to here in this particular Ubuntu machine, this is the editor, gedit. Okay, so here just you have to give the configurations and all. So what you're looking for the end related. End means at another resource negotiator. So in tomorrow's session, I'll be explaining the complete architecture of generation 2, and you can do some comparisons with the generation 1 also. And then you at that time I will come back to this and I'll explain what exactly this. Right. So like this way, what the admin people will do after downloading the Hadoop and extracting that into a normal thing, then they will configure some important files like this. So after downloading Hadoop, for example, if you open this, okay, so this will be blank. That's it. You don't have this. Okay, so you don't have any parameters like this. Only you have this some some information like this. But these parameters, everything has to be set manually. Okay, for a small scale and all, the admin people will do this configuration manually. But in real time, if you suppose they're maintaining very big clusters, that time they will use Ambari. There is a tool called Ambari. Okay, Apache Ambari. So in that Ambari, they will configure. Just they will input the parameters. What is the cluster size? What is the total size? How many nodes that they're having? How many racks that they're having? So everything will be specified and everything will be set automatically. So it will go and connect, in the background, and it will go and fetch some libraries from the Maven or any third-party libraries. So like the way it will fetch and it will install. So no need to do any manual intervention. Okay, it depends how the admin people will really do the installations and all. So maybe they can go with a manual thing or they can use the Ambari. It depends what kind really they're going to choose and what kind of installation that they're preferring. So while doing with the Ambari, so default settings will be made, right? Of course, afterwards you can change that. But if you're going with a manual, you are having your freedom, right? You can set, sorry, you can set it and you can give your own thing and all. So it depends. Anyway, just keep in mind in real time is settings and configurations, everything made with the help of Apache Ambari. That's fine. Now, what about the other important ones here? So far just we visited the etc. So here In ETC, what are you going to have? Just the installation folders in terms of storage and processing and resource management. So HDFS related and related everything, all the important configuration will be existing on this particular folder called ETC. Then, what about this SBIN? So if you see here, we are having some .sh, okay, some .sh here, like slaves.sh, start all.sh, start balancer.sh, stopped all.sh. So you're having some .sh, right? Sorry. All these are executable shell scripts. Okay, all these are executable shell scripts. So with the help of this particular shell scripts, you can start or you can stop the Hadoop services. Okay, got it? So because we are having certain services, right? For example, let me write something on the notepad so that I can share it to you later. Suppose you're talking about generation 1, just please do remember this. Okay, so we are having something like name node, data node, secondary name node, job tracker, and task tracker. So these are the some services, right? At the same time, if you're referring to the generation 2, okay, on this is known as n, nothing but n, yet another resource negotiator. Okay, so here this remains same, name node, data node, and secondary name node, and this is optional. Of course, we have not studied the architecture. In tomorrow's class, we'll be understanding very clearly why I'm saying that is an optional. And surprisingly, you're having not the job tracker and task tracker, you'll be having resource manager and node manager. Okay, so here this is the master and this is the slave. You can say slave or worker node. It's up to you. So this is only checkpoint node. Right. And this is about master. And this is once again slave or worker. Let me copy. Fine. And here also same thing. Okay, here also same thing. There is no change at all. But this is optional here. I'll put some star also. Why I'm saying this optional. So in tomorrow's class, I'll be getting complete idea. So coming to this resource manager, this is the guy who is acting as a master. And coming to the node manager, so this be acting as your slave or worker. So like what happened to the job tracker and task tracker in generation 2 or nothing but on air. So we'll be getting those details in tomorrow's class because elaborate conceptual discussion we'll be having in terms of the architecture. That time I will discuss. Okay, but please do remember these names. So name node, data node, secondary name is an optional. So I'll tell you when it is optional, and resource manager and node manager. So these are the 5 names that you need to keep in mind. Okay, just remember. So these are about storage and this is about resource management. So we'll be understanding this later. Okay, right. So here we're talking about some script, right? Like start all.sh. So the moment you are giving this executable executable script, nothing but you're running this executable script, all the services will up and run. Okay, all these services, name node, data node, secondary name node, resource manager, and node manager. So everything will up and run here. So that is the purpose of this start all not sh. So the beauty here is you can start all the service at a time, or you can start the services one by one also. So that you like, you can start the name node followed by the data node and secondary name node, then the resource manager and node manager. So like the way you can start the services, or alternatively you can give this simple command. So this will start all of your services, but in real time this is not recommended. Okay, this is not recommended because at a time it's give a lot of load on your cluster. So in real time we'll be starting the services one by one only, like a name node, data node, secondary name node, and resource manager and node manager. Okay, but here of course it's our own thing and we can do a lot of experiments here. So at the same time multiple user interface is also not there. It's a very simple configuration what we made in this machine. So here you can give this, here you can start all your services at a time. I will show you the alternative way also. Similarly, you can start only the HDFS related, like you can start only the name node, data node, and secondary name node by running this executable shell script called start-dfs.sh. Similarly, you can stop those services using this stop-dfs.sh. So similarly, you're having stop earn and start earn also. So resource manager and node manager will be stopped and started here. And this command, this executable shell script, start all the demands at a time. Okay, so we'll see now what exactly. So please do remember the important, the etc we are having all the configuration files here, right? And in this particular sbin we are having some executable shell scripts to start and to stop our Hadoop daemons or services, right? And one more thing called a folder name is here share. So here not that much, but the only thing is you're having some example jar files here. Yesterday we have seen a word count program, right? So that related jar files will be existing here. Examples 2.3.0.jar. Okay, so apart from this path, okay, the shared Hadoop map reduce. So you're using rigorously two important locations. One is sbin, and one is this particular etc Hadoop, right? To verify the configuration settings and everything to start and to stop the demands, and all these are pretty much needed. That's fine. Okay, is this clear, Nadesh?
Yes.
Right, fine. Now here you're having a terminal right here. So this is something like in a command prompt what we can call in, or we can compare with your Windows machine. So we are having a command prompt, right? So like this, you're having a terminal here, what we call. So let me close this. Some Kafka service is running. Fine. So right. So what we call this is the terminal. So you can click here. Otherwise, alternatively, you just say Control Alt T. So this Control Alt T just opens the terminal for you. So like this, you can open n number of terminals. There is no restriction. So alternately, you can go and search the type here, search button also. Like you just say TER, so that will give you the terminal here for you. That's taking a lot of time here. I don't know. Right, this is the one. Right, you can go with any of this method based on your convenience. That's fine. Now let me zoom in a bit. That's fine. Right. So this user, I just created, and we don't have any separate users for Hadoop. So this is the root account, nothing but in our Windows, you are having some admin account, right? Who is having all the privileges. So if you're creating any guest user or any other user accounts, so we'll be giving some privileges, right? So we are giving some authentications and some permissions we are granting. So here, as I'm doing everything on top of the user account, nothing but the root user. So I don't have to worry about anything here. So I have not created any separate user for Hadoop echo operations and all. Oh, that's really good thing. And here my host name is localhost. So you can keep while installing your operating system or nothing but the Ubuntu. Here there I mentioned my host name as localhost. But in real time they will you go with a different terminology and all. And you can keep your name also localhost as you can keep your name like Naresh also. Even that also works. So don't think that it's a convention that you need to follow. It's not like that. But I have not done any modifications, so that's the reason it's showing host name is localhost. That's fine. Now I just open this terminal. So as a Hadoop developer, your first job is to verify whether your Hadoop is running or not. Okay, whether your Hadoop server is up and running or not. So how you can verify that? The simple thing here, JPS. So this JPS is not related with your Hadoop command. This is related with your Unix command only. Okay, this command just tells us what are the various running background Java processes. Okay, I'm repeating once again. This command is a Unix command and just it gives the list of Java processes which are running in the background. Okay, right, that's it. So here I got back just JPS only written and it's saying nothing here. So this means that my Hadoop is not up and running. Because if Hadoop is up and running, I have to get these services like name node, data node, secondary name node, resource manager, node manager, because I'm referring to generation 2 here. Okay, so these services should appear when I hit JPS. If I'm not getting, that means that my server is in sleep mode or in offline. It's not working, right? So then how to start the Hadoop services first of all? So here we just seen, okay, there is something like Hadoop 2.3.2. Here is a folder for etc, not etc, just a minute. Here in this sbin, you're having all the executable shell scripts, right? So we'll use this command to start all the services, or we can start the services one by one also. We'll see both the ways. I'll show you. Right, how to start this. So at present, I'm under this home user path. So let me go to the Hadoop installation folder by saying cd Hadoop 2.3.2. Okay, cd is something like a change directory. So I'm going to this Hadoop 2.3.0 and hit enter. And there is one more command called ls, or you can say ls minus ltr also. Just go with ls, not a problem. So this ls command will list all the files and folders. So here you'll be getting the same thing, right? So what you have is manually. Here physically we have seen this same thing, right? Yes, these are the folders what exactly appearing here also, bin, etc, include and everything. Now just go to this particular sbin folder once again. So just use the cd command once again and say sbin. Now I'm under the sbin folder. You can see this pwd, nothing but it's providing the current working directory or present working directory. So this is the current working directory, right? Now if I say ls, here I'm getting a lot of commands, same thing. I'm showing that commands, that's it. How you can verify, because in real time you cannot see like this. Everything has to be done with the help of commands only. So this is our own machine, that's the reason we are flying from here to there and there to here. But in real time you're not getting any access to go and see your installations and all, right? So same shell scripts, right? What exactly we are getting here, right? So first of all, I will show you how to start the services one by one. Then I will show you how to start at a time. Right. So first of all, we'll start about Hadoop demands Hadoop demand dot sh start name node. So this dot slash is used to run the executable shell scripts. Okay, what for I'm giving this dot slash? Because I want to run the executable shell script. So right, that's fine. So dot slash Hadoop daemon dot sh start name node. So this command just starts my name node. Okay, you can verify with the command jps. So earlier I don't have any name node. Now I got the name node. So what about this 8747? This is the process ID. So actually we don't have any role to play with this. Okay, admin people will use these numbers, right? This process ID is what we call to kill certain process. But as a developer, nothing to do with these numbers and all. Right. So what we did, just we started the name node. In a similar fashion, we can start the secondary name node also. Dot slash Hadoop daemon dot sh start. Okay, start secondary name node. Right. Right. I got my secondary name node also. Now I'm going to start my data node. Start data node here. Right. Sorry. So now if you look at here, just we got all the Hadoop related daemons here. Okay, we just started these things. So forget about this JPS and all here. So data node, name node, and second name node. Don't think that everything will become in an order. It's not like that. That's fine. Now we have to start the resource manager and the node manager also. And these are related with yarn. Okay. Now we'll start those daemons also. Right. So dot slash yarn daemon dot sh start resource manager. Okay, this command what it will do, this will start your resource manager. Right, look at here, I got my resource manager. Now I just left over with my node manager. I'll start that even. So n daemon dot sh start, okay, node manager. Right, so just I'll verify once again with the help of JPS. I got all the daemons here. Okay, this resource manager and the node manager. So these guys also now started working here. Sorry. Right. So this anyway it's working earlier only, so I'm taking this. That's fine. Right. So apart from this, we need to start some auxiliary service called history server. Okay, job history server or history server. Okay, so we have to start that. Actually, that is not required for your normal MapReduce programs. That is only required for your pig programs, Apache pig programs. But anyway, I'll show you how to start the daemon here. Okay, so that is not related with your Hadoop or with your Yarn. That's an auxiliary service which really needed to run your pig jobs. Okay, so while discussing about the pig, I'll let you know why we are starting the map that MR history server and all. Okay, I'll give the clear-cut explanation that time. So mr hyphen job history server, sorry, job history daemon.sh start history server. Fine. So this is how you can start your complete Hadoop. So once you started all the demands, please don't do anything here. Just say cd and just come out from there. Okay. And here you can check once again if you don't need it. That's fine. So here you can get the data node, job history server, node manager, resource manager, name node, and security name node. So everything is now up and running. Okay. So this is how you can check the status of your Hadoop machine, whether it's in online or offline. If it's offline, this is how you can start. Now, this is known as command line interface. So apart from this command line interface, Hadoop provides web user interface also. Okay, we'll see. Okay, that's the moment. It's taking some time here. So this is about your name node page. And if you click here, browse on the file system, it will take to your data node. So here I'm having something, right? Some files and directories I'm having. So this is known as, this is known as data node location. This slash indicates, we are referring to a data node here. See here, the moment you have given this localhost 50070 dfs health.jsp, that will be taken to your name node. This is the name node page. So if you click on this, browse the file system. So here the information what you're getting on the screen is related with your data node. Okay. Now here you can see the cluster summary, also everything is given here. How many file and securities off, because I have not implemented any Kerberos level security and all. So it's saying security is off here. There are some 54 files and 16 blocks and some information it's giving here. How much memory it's having total, 27.44 gigabyte, and like that it's giving all the information here. How many blocks are used and how many still are free to occupy some memory, and what is the heap memory size. So everything, at the same time here you can get live node only one, because it's a single node machine. We don't have any multiple nodes. So if you're having multiple nodes, then you be getting, if and all you're having any dead node. Nothing but yesterday we discussed this, right? So some nodes fail to give the heartbeat. So your name node treats or considers that particular node as a dead node. So such information will be available here. At the same time, you'll be having some decommission and commissioning. So we are having a concept called commissioning and decommissioning in Hadoop. What do you mean with that commissioning? Nothing but adding more and more machines. Suppose today you're having 10 machines and the other day you just added 5 more machines. Okay, so that is nothing but commissioning. Due to some, maybe you just felt like that this many servers are not required, or this many machines are not required in my cluster, and you just removed some of the servers, like 3 or 4 you have taken away. So that time you just, what you did decommissioning. Okay, so if and all, after starting your cluster, you have added some boxes or deleted some boxes, those will be given as a list of decommissioning and commissioning nodes here. Of course, nothing has happened. This is a single node machine, that's it. And here you can see some other information also, like here you can see name node storage. So while discussing about the name node, we are talking about the metadata, right? FS image and edit logs, right? That's a core of your metadata. And this metadata generally will be available in name node's main memory, nothing but on the RAM. But apart from that, okay, what we understood, secondary name node maintains this name node's metadata in disk space also. So this is the location of that. Okay, so this is the same thing. Periodically, for every 1 hour, it's collecting, right? And it's collecting the FS image and log files, and it's applying the log files to FS image and providing the consistent metadata. So once it's preparing, that is stored here in this the disk space and one in the main memory. So this is about name node storage, and down here you can see and a lot of. Here I'm getting a lot of loading FS image and all, loading edits and all. So whenever I'm restarting or periodically for every 1 hour, secondary name node is going and connecting and it's doing all the activities. So when it's happened, right, it's giving all the metrics here. That's fine. And in the bottom you will have the new user interface also. So if you're comfortable with this, you can continue with the same user interface. But if and all just you want to go with a new user interface, you just click here the new UI. So all the way you're getting some fresh look here. Okay, so if you click here, you'll be just getting the name node related information here. Okay, the same thing. And if you click the data nodes, you'll be getting the information about the data nodes, what is in operation, and if and all any decommissioning is happened, under replicated blocks and over replicated blocks, and everything will be coming here. And here you can take the information about the snapshot. Of course it's an empty, we are not taking it all. And you'll be having some startup process and all, right? And here in the utilities you'll be having browse the file system. So this will show you the contents of your Hadoop. Okay, data node contents, I mean to say, right? So these are the contents, right? Home, test op, and tmp, some folders we are having, some files and folders. So here you can see those details. Okay, so here you can see block size is 128 MB. Okay, this is the default block size, and replication is 1, and this file just occupied 154 bytes. That's it. So only 154 bytes is created now. Don't think that it's created 128 MB and we wasted the rest of thing. So based on your interest, either you can use the new API, new user interface, not the API, sorry for that, new user interface, or you can go with still the old one. Okay, so it's up to you. Right, so you can use this or that, even it's up to you, right? So based on your convenience, you can use any of the version. All right, now we'll start with some basic commands. So what we did so far here, just we started the services, nothing more than that we did, just right. Fine. Now how to stop this Hadoop? Okay, just to go to the installation folder once again by saying cd Hadoop and sbin. Okay, so directly you can say stop all.sh. This is a single command which stop all the services apart from your history server. Otherwise you can stop one by one the services also. For example, you can do like this: hadoop daemon.sh stop, stop. name node. Like this also you can stop one by one. Okay. Similarly, you can stop the secondary name node and the data node. So we stopped all the Hadoop daemons here. Now we will stop the errand related daemons. Okay. And the node manager. Okay. So I already mentioned, right? The job history server has to be stopped manually. All right. So now if you verify with JPS, so we are not having any Hadoop daemons. This means that your Hadoop is not running. Even you don't going to get nothing here. So it's not able to get the things. Right? Fine. So now how to start all the daemons at a time? So just you can say start all.sh. So this is the command you can give to start all the daemons at a time, but you get some deprecated and warning messages. Please don't start like this. Start the DFS initially and followed by the end like the way. But okay, it doesn't care about that. It's not a problem. But in real time, this is not recommended. And some executable shell scripts will be blocked by your Hadoop admin. You won't get any access to, start and stop by your own. Right. Fine.
Yeah.
So if you say JPS, you will be getting all the services apart from the history server. So based on our requirement, you can start the history server by saying mr job history server daemon.sh and start history server. That's it. That's it. Okay. So right, our Hadoop is once again up and running. Even you can get the web UI also here if you refresh this page. Right, we got back everything.
Yeah.
Fine. So right, we'll take 5 minutes quick break, and after that we'll just continue the Hadoop commands. Initially we'll just start with some Unix commands, and then after that we'll be working with Hadoop commands also.
Yes.
Right? Yeah, I'll just come back within 5 minutes. So right. So Naresh, shall we start?
Yes. Yeah.
Any doubts? Are you okay with this?
Um, for now, okay, but I need to. I'm thinking to
Okay.
like I need to see video for one more time. I think so.
Okay, not a problem. Because anyway, this will be shared and virtual machine will be also available to you, and a commands guide also I will give it to you so
Okay.
that you can practice that. It's not a problem.
Yeah, sure.
Fine. So far as we understood, how to stop the Hadoop daemons and how to stop and start, of course, and the important configuration files and all. That's fine. Now we know the data, will be available somewhere. Not always. The data will never available directly on the your Hadoop machine. So you have to bring it the data from outside world, maybe from your Oracle servers, or you may be connected to some point of point of sale data, sir, or you may be connected to some IoT sensors data. So data will be generated outside the world, not in the Hadoop, right? So what we have to do, the generated data has to be bring to the Hadoop. We have to store that, and then we have to start processing the data based on our requirement or the problem statement, what we can say like that, right? So coming to this, so while working with the Scoop and Flume, we'll be working on streaming and import and export activities and all. But now you just understand, if you're having some data on local bus system, how you're going to copy to the HDFS, and what are the various options or what are the various commands. So everything now you're going to identify, right? And before that, I would like to show a few more things. Okay, right. There is some detail. Okay, anyway, I'll give some commands guide to you, that there you can just refer, the default ports and the web ports and everything, the RPC ports I mean to say, right? For example, for every port, for everything, we're having something like, web port and RPC port. Okay, like you can say some demand name and say web port and some RPC port. So these are the common things, like, data. For example, you're talking about name node, the web port will be 50070, and the RPC port, it may be 9000 or 8020. Similarly, for your data node, the web port will be 50075 and RPC will be 50010. Okay, and 50020, and so on. Yes, like you can go with your resource manager. This will be 80 applied, the web port, and RPC port 8030. Okay, right. So like this, coming to this node manager, 8042 and 8040. Right. And we do have one more thing called, right, job history server, right? So coming to this job history server, 10020 is the web port and 19888, this be your RPC port. So it depends. This is the, like, how I got this list means this is from Apache documentation or Cloudera or Autonomous. So all these guys follow some universal standard things, right? To refer the name node, web port will be by default 50070, unless your admin people got changed that one. Right. Now we'll go with some commands here. First of all, I'll start with some basic Unix, then we'll go with the Hadoop level also. Right. So for that, just I'm opening a terminal. So it's already there anyway. I will use the same. So already we identified JPS is to list out all the background Java running processes. The background. So to get the correct Hadoop version which is installed on your machine, you can say Hadoop version. So 2.3.0 is the version what is present at in this particular machine. Similarly, if you want to verify the Java version, so 1.8 is available in this machine. So you can have 1.7 or 1.8 for the generation 2. And coming to the generation 1, 1.6 is highly recommended. That's it. Like the way you can verify host name also. And of course, host name is directly appearing here as a local host, but just you can verify with the name, host name is localhost for me. And to identify the IP address, we can say if config, something like IP config.
Yeah.
Okay, yeah, in your Windows machine. So if you give this if config, then you'll be getting the IP address here 192.168 and 146 and 176. So there is two kinds like dynamic IP and static. So based on the configuration, the admin people made that into static or a dynamic one. Okay, based on their requirement and standards. And coming to this, we do have the loopback IP address also. So while communicating this particular host with any other thing, like when maybe you want to communicate with your you know MySQL server or Oracle. So if you want to communicate with your host, that time you can use this particular address in the connection string. Like I think you know about this JDBC ODBC connections, right? So whenever you're kind of communicating with something with a different front end and back end kind of thing, in a similar fashion, suppose your data there in the MySQL server or any Oracle kind of thing, and you're having some databases or tables that you want to move or import, nothing but or export. So that time in the connection string, you can use this particular IP address, or you can use this loopback IP address also. That's fine. Now we do have something like sudo, nothing bad. Let me type here sudo gedit dot bash rc file. And see, please remember whenever it's prompting a password, the password is Hadoop. Okay, everything is in the lowercase, right? So in this bash rc file, we'll be having all the configuration settings. The path, home path, just we have given here about your Java, Hadoop, and the big Hive, HBase, Uzi. So all the components are all Hadoop stacks that what exactly you're using. The home path will be set under this particular .bash rc file. Okay, and please don't do any changes here. If you're going to do and they may not work, you're going to disturb the thing. Was just an idea, just remember this. Sudo gedit dot bash rc file to get the configuration details, nothing but to verify the home path related stuff and all. Right. At the same time, you can check the Java home path also. See, this is only just giving the Java, I mean to say the version only. But if you want to get the path, there is one more command called name I and user bin Java. So there's the path. Okay, this is the path where exactly where Java is installed. Here where JDK and JRE, Java Runtime Environment and Java Development Kit here. So i386 stands here. You just install the 32-bit. That's it. Okay, right. So that's about your Java home path and all. Now, see, if you want to create a folder on this desktop, so generally, in Windows, how are you going to do? So you're using your mouse and you're saying new folder, then a folder will be created. And after that, you can put some name also, like this folder name is APC kind. And you can click here, and if and all it's required, you can create a file also. For example, if you want to create a file, you can say just new document, and you can say empty document, and you can put some name here, test1, and you can write something here. Okay, hi, how are you doing? That's fine. So you can write some text here, and you can close this after saving. And the same thing if you want to do with the terminal, and by using terminal I mean to say if you want to create with the command, so just open the terminal. Okay, and where you want to create on the desktop, right? So just change your directory from this to desktop. So just say cd desktop. So now you are under the desktop folder. Here you just create your desired one. So how to create a folder? By saying mkdir space and give the folder name. For example, you want to create a folder with a name called test28. Just I'm taking today's date. So where folder name is test28. That's it. That's how you can create. Look at here on top of the desktop. Now you're able to create that test28. So in this particular test28, if you want to create a file, how are you going to create? So first of all, go to the respective directory by saying test28, and here you can use the gedit. So I already mentioned, right, you can use va or gedit. So you can use the gedit here. So gedit space and just provide your file name, like you want to I want to create a file name with sample28. This is my file name. So here a file got open for me here with the name sample28. So write something here. Hi, this is my test file. That's it. Okay. Now if you want to view the contents of the file, okay, you don't want to edit, but just you want to view the contents. So for that you can use cat command. Cat and just provide the space and followed by the file name. What is our file name here? Sample28. So look at here, the content is displayed here on the console itself, but we cannot edit, right? We cannot edit. So cat space and the file name to view the file content. Example, if you want to edit this, once again you have to use this gedit, the file editor. So gedit and sample28, nothing but our file name. So it's open for me in edit mode once again. So you can write your content once again here. Right, and now save this. Okay, and to view the file list of files and folders, you can say simply ls command. So here we are having a file called sample28, and don't worry about this. This is a temporary file. That's fine. Now, if you want to do the same operations at HDFS level, nothing but at Hadoop level, how to create a folder and how to copy a file. Unfortunately, we cannot create a file, right? Already I mentioned. So in Hadoop, you can create a folder or a directory, but you cannot create a file. Okay, right? So we'll see how to do that. So just I came out from here, right? Now, after opening a terminal, you just say HDFS. First of all, verify your Hadoop is up and running or not. It's fine, it's there. Then you just start issuing these commands like HDFS, DFS, minus, or you can say hyphen, mkdir space slash. So this slash indicates you're referring to a data node and provide the name. Okay, so I want to give a name like a test, you know, 0828. So this is the folder I want to create. Okay, same mkdir command only, right? But here I just added HDFS DFS. This differentiates from your normal Unix command to your Hadoop commands, because Hadoop is also a file system on here, right? So now, so HDFS DFS space minus mkdir, and this slash indicates that you are referring to a data node location. Just say test 0828. Any name you can provide here, that's fine. Any name you can give here of your own. I will just go and verify here. See here, initially you'll be having this, and just say browse the file system. Here you can see a folder is created, and you can see the timestamp also here, and it's giving all the permissions. So of course here I don't have any user groups and everything, so that's the reason it's showing everything on top of the user account only, normal user. That's fine. Now, so what is it? I cannot create a file at HDFS, but what I can do, I can copy or I can move some files from local file system to Hadoop. So something like I'm having a file here. Okay, something like I'm having a file on my desktop, right? Otherwise, for to simplify the discussion, what I will do, I just copy this file to HDFS here, right? Now some sample 28 is there, right? And I want to copy this file to HDFS. So how I can copy? Just go to the CD desktop and say HDFS DFS minus put or hyphen put, you can say. So we can having one more thing called copy from local also. I will show you that later. So HDFS DFS minus put space, and the file name is sample 28 to where you want to move. You want to move to the HDFS location. Clear? So this is how you can take the file from here to HDFS level. Right. Just hit enter. Right. So here you can see, just click on this test 0828. Oh, sorry, we just copied to HDFS only, right? Not the folder. Yeah, here you can see that sample 28. So this is the file what we copied from my local file system. Earlier this is in the local file system. I just copied to this HDFS by using the simple put command. So this put command and copy from local both are equal. I'll write that later. For example, you want to copy this to this particular folder, just modify your command. Like you can say HDFS DFS minus put sample 28 to where test 0828. Now what I did, earlier we created a folder, right? Test 28. this one, just 08 and 28. So to that folder, I just copied this file. Here you can see there's a one folder. Here you can see the file. Okay. Now, if you want to save this with an I mean to set some with other name. Okay. If you want to save this, file content will be the same, but just you want to save with a different name. So same thing, and here you just specify the new name. Okay. So you can say new sample 28. So what happens then? The same file. This will be saved with a new name called new sample 28. Of course, the content remains same here. Okay, we'll just verify. Okay, got it. New sample 28. Of course, the content will be the same here. The content will be same here, but we'll just save with a different name. That's it. Fine. Now I said we cannot create a file at HDFS, isn't it? So if you say HDFS DFS minus gedit, this is a file creating command, right? So if you say HDFS DFS minus gedit and provide some name here like my test. This is the file I want to create at HDFS. Here it's saying unknown command. So you cannot use the gedit, not only gedit or via any editor. So you cannot create any data at HDFS level, and even you cannot modify also. For example, here you're having certain data.
Yes.
So you cannot modify this data. Like just you want to say you want to make this into uppercase, or you want to add few more lines here in between this. So this type of operations are not possible. But you can append the file. If you are having another file and if you want to append that file content to this file, you can do that. I will show you that later. So there is some merge commands will be there and appending commands. I'll show you that later once you are familiar with these small commands. Okay, but just understand that we can copy or we can move the file from local file system to Hadoop, but we cannot create or we cannot update existing file. All right. Now what I said, there is one more command called, the same one. So either you can use the put command or alternatively you can use copy from local also. Suppose you're having the file called we'll create. Okay, not a problem. I'm verifying is there any other files on there. Okay, so I'm having some file called test1. Okay, I'm having some file at test1 with a name on my desktop here. So if I want to copy to HDFS, either I can use put or alternatively I can use copy from local. So how to use that? So cd desktop, because the file is there in the desktop, or from home also you can move, but you have to provide the complete address. I don't want to confuse now, so that's the reason I'm not giving that. So from where now, like just after opening a terminal where the file may be existing in any nested directory structure, but from there itself you can copy or move anything. But the problem is you have to provide the complete path. That's it. Don't think that you every time you have to go to the respective file location. It's not like that, right? So alternatively, you can give everything from the home itself, but you have to give the complete path. That's it. Now you can say HDFS, DFS, okay, minus copy from local. Okay, and the file name is test1 to HDFS. So both are identical. Let's put or copy from local. Right. Now here you can see. Okay, we got this test1 also to HDFS just now. That's fine. Now if you're having some data at HDFS like this, and you want to take this from HDFS to local file system, the opposite way, right? The opposite way. So if you want to take this high backward compatibility, some file is there in the HDFS and you want to take this file to local file system. I'll just delete this. It's there. So we'll be using a command to get the, get back the things like, from here. The file what you're having at HDFS and we're just getting back to our desktop. So how to do that? So for that, you can use the get command or you can use copy to local. I'll show you both the things. Okay, so let us write the get command first. HDFS DFS minus get or hyphen get, you can pronounce it like your convenience, and the file name is high, very big name, backward, and comp. This is the file. And where you want to get? You want to get to home user desktop. So home user desktop. That's it. Right. So here you can see we deleted this earlier, right? We got back the, just we use the get command to take the things from HDFS to local file system. That's the opposite way, just it. Now apart from the get command, you can use the copy to local also. I'll show you that also. Let me cut and paste somewhere. For the same file I will show you. So instead of this get, just use copy to local. Okay, copy to local. That's it. Right, we got here. So these are all, these two are identical, like the way, the put command and copy from local are identical. In a similar fashion, this get and copy to local are also identical here. That's why. Now we're talking about some appending, right? So we're talking about some appending. We cannot update or we cannot create something, but we can append. So what I will do now, we'll take a file here. Yes, I'll take this file. So this is my first file. Like this, I'm having some sample data right here. So what I will do is I will append the file content of this. Okay, something I'm having a sample file on my desktop. What I will do is I'll just append this file content to this. Okay, with the help of appending. So how to do that? Right, let us write the command for that. So DFS minus append to file. Okay, which file you want to append? So you want to append a file called home user desktop hive underscore backward compatible. So this is the file what you are referring here, and you want to add this to which file? So not add, append sample 28. So we are making the same thing here. Okay, here I'll give the same thing, sample 28. Right. So what I'm doing here, I'm just appending a file which is available in the local file system. Home user desktop high backward compatibility. This is the file, and I want to add this content to this sample 28. Let us do, and even we verify also. Fine. So at present it's not taking any effect. So just refresh. Okay. So got it. So this is the other file, right? But you cannot modify this content. This remains same, but we just append it. That's it. Is this clear? Right. Now in a similar fashion, even we can do some merging also. Suppose you're having multiple files at your HDFS file, right? And you want to copy that into a single source file. Okay, you can do that also. How to do that? Suppose here I'm having some sample 28. This is my first file, and any other file? Yeah, test one. This is my second file. So two files I'm having. So if I use get command, what happens? A single file will be created. But what is my intention? I want to combine these two files output to a single file. I want to merge. So I want to merge this sample 28, this content plus this content, just one. And I want to save this particular merge file at a desktop. Okay. So how I can write the command for that? So as dfs minus get merge. Okay. And the files. So one file is test one. This is the file. And what about the other file? The second file is sample 28. Okay. Sample 28. And you want to create a merge file on the desktop. So let us give the same thing here. Home, user, and the desktop. And just provide the new name. So just I'm saving this as a Naresh merge file. Okay, right. So here these two files related are available in my HDFS, and I'm merging these two, okay, to provide the single file. Right, we just will go and verify here. Where is that? Here I can see arrangement file. So it's combined our two files. Okay, so hi, how are you doing? So this is the first file, and from here the second file started. Hi, this is the test file, like this. Got it? So like the way you can merge files also. Right. So any doubts? Are you following this? Yeah, Naresh, is this fine? Right. So shall we stop the discussion here or will continue? Are you following?
Uh,
Is this fine?
yeah, I think so. I will go through video for some time, so okay, we can continue tomorrow. It's a
Okay.
little bit like feeling a little bit difficult for me.
Mm-hmm. Right. So please do the practice. I'll share the video and all. And the business also will be uploaded. I think I had to compress this and I had to keep in the drive. Okay. Because earlier I'm having one machine, but I used to give, but I changed some modification this. So that's the reason I want to give the new one to you. That's the reason
Yeah,
I
sure,
want to
sure, sure.
upload it. Okay. Right. So we'll start the discussion here, and tomorrow's class we'll be working with some more admin related commands and some useful commands. Even if you are working on a small scale industry or some small scale, really, I mean to say some a company, a client. If you are working, sometimes what you have to do go with some admin related commands also. So I will show you some admin related commands, and we'll understand the yearn architecture also, and we'll try to compare how it is different from the generation one architecture.
Yeah, sure.
Okay. Yeah, that's about our tomorrow's agenda. And please go through this file once again and try to practice the commands. So, is this fine? I'm in
Yes,
good pace. Are you following the content what I'm delivering?
yes, yes, yes.
That's great. And one more thing, just I received the payment also. I would like to confirm that
Okay, you got
yesterday,
the amount?
yesterday just received a mail, but not into my account. But today it's credited with that. So that's the
Okay,
reason
okay.
just I'm going to my email. Yeah, that's a good thanks. That's fine. Fine. Thank you. See you tomorrow.
See you too.